Hello everyone, welcome to the series of Laoss tutorials. We are going to start about the Laoss softwares, that means large area organic semiconducting simulation software, and in this tutorial we are discussing about the Laoss softwares and their first tutorial Oled Simulations. So before start of my tutorial I am going to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. And Impulse Technology, which have partnership with Nano Academic Technology, which offers several softwares like NanoDecals. It is used for the material and device simulations and rescue softwares. It is used for the material simulations and QTCAD. It is one of the software it is used for the spin qubit material simulations. FluximAg, it is a Switzerland-based company which is develops various tools that work on the research and development parts, and in here we are going to discuss about FluximAg developed software like Laoss software. It is a simulation software for upscaling to large area device in OLED and solar cells that help also analyze electrical losses in large area electrodes. Our company provides many services like software distributor, training program, technical support, and equipment. We have also some of the micro probe stations like solar cells, thin film, FET, gas sensor, transistor, and memoristor. So you can see at the downside we have valuable customers like IIT Madras, IIT Guwahati, IIT Dhanbad. So you can see in here the number of the customers that uses SetFOS and Laoss software. About the company, FluximAg, it is a Switzerland-based company that develops scientific tools that help to boost our research and development part. In here, it is a simulation software that used for the upscaling for the large area measurements, hardware of the OLED, perovskite solar cell, OPV, and electrical properties. Outcomes generally based on the computational physics that the Zurich University of Applied Science Dr. Pete Hessler founded that the FluximAg is a spin-off company. So some of the softwares that given in here, SetFOS, Laoss, PEOS, Philos, Laoss Lite. Each of the software work on the simulations part like SetFOS software. It is a simulation software for the organic and inorganic and perovskite tandem solar cells and OLEDs. And the Laoss software, we have already told, it is a simulation software for upscaling to large area device for OLED and solar cells. Also help to analyze number of the electrical losses in large area and PEOS software. It is used for the electrical characterization of OLED and solar cells as used for the transient photoluminescence and transient photocurrent. And one of the Philos software, it is an angular luminescence spectrometer to characterize the light emitting device. Simple word we can say, angle dependent electroluminescence and photoluminescence spectrum measurement we can done in here. And Laoss, it is used for the stress test platform to degradation analysis of LED. It is an advanced LED stability lifetime measurement system. And Laoss Lite, it is a platform to perform parallel JV and stability measurement on organic perovskite solar cells and perovskite arc tandem solar cells. If you want to more information related to this, you can visit on the FluximAg company and their website and Impulse Technology YouTube channels as you are seeing. So you can visit on this. In here we are only discuss about that Laoss software. So we are going to discuss about the tutorial of the Laoss softwares. So in here we discuss with the small PPT. Then I will show the demo parts how we can use Laoss software, and I will show one of the tutorials Oled Simulation. Large area organic semiconductor simulations. It is a powerful software package that designs simulations and optimization of large area organic and perovskite solar cell, LED, display, lighting panels, photovoltaic array. The key feature of this software, FEM based electrothermal modeling in here, powerful 3D ray tracing for the concentrator PV, wide range of different output data and comprehensive result visualization, high speed computation on standard PC initiative. Their GUI is too much easy to use and workflow. We can also integrate slash and SetFOS softwares. That means SetFOS results we can also simulate in the Laoss software. In the Laoss modules, they divided in the three parts: electrical modules, thermal modules, and optics modules. In the electrical modules, you can see we can simulate the characteristics of large area OLED and solar cells, optimization of the electrode design, reduction of electrical losses, studying non-ideal effect in OLEDs and solar cells, understanding electrical crosstalks in RGB OLED pixel array, and thermal module. In here we can couple electrical plus thermal also, because without the electric we can't calculate that thermal property in here. So you can see couple electrode thermal model to simulate two-way interaction between heat generations and electrical properties of the semiconductor. Calculate the temperature distribution in OLED and solar cells under standard operations. Explaining non-ideal IV characteristics of OLED and solar cell due to electrical thermal couplings. We can use that type of modules to calculate temperature type of problem. And it is a optics modules. Optical simulations with a powerful 3D ray tracing algorithm, modeling standalone 3D optical elements and their contribution to the device, and simulating optical crosstalk in OLED pixels, easily coupled to set files to analyze OLED and PV with complex light coupling geometry. So these are the modules available on this Laoss semiconductor simulation software. You can see I will show in the demo parts. You can see new project, load project, save project, that options available, and you can run in here project properties, command line, and simulations. So too much easy to use the GUI with the single platform. You can analyze different properties in here. So at the next slide, what is the actually usage of the Laoss software? Drift diffusion modeling. Generally they based on the Poisson equations and drift diffusion equation for electron and holes. They simulates carrier transports, recombinations, and generation process. They supports multiple layer, defect states, exciter, and contacts also. After electronic simulation, we can also do Laoss can be coupled with the set force for optical simulation, use light generation profile from set force to simulate photo generated current, and transient and steady state analysis like JV curve, CN or CT, TSC, transient photocurrents, and more types of value you can calculate. They are suitable for both DC and AC characterization. Multi-physics capabilities, like it simulates the effect of the temperatures, like we have told already in this previous slide. Thermal modules are available. Trap states, ion migrations, interface recombinations, and series or shunt resistance. User-defined model and parameters. They support custom materials with parameters like mobility, band gap, density of states, and permeability. Allow defining non-ideal contact behavior, surface recombination, and defect density. So these are the actually uses that are available. So not only that things are available, you can also visit the FluximAg and you can check our research paper on this. Now we are going to discuss about the tutorials how we can simulate OLED simulations. But before the start of this tutorial, we need to create in here the geometry, because in large area simulation we can do in here. So firstly we need to create one of the geometry for the OLED simulations. Now we are going to open LibreCAD. It is a freely available tool you can use directly to create one of the geometry like this. So LibreCAD tutorials are available in the YouTube. You can also check, but we are going to discuss in here the geometry parts, how we can create the geometry like 100 mm and 100 mm length and 100 mm width. So that type of geometry we can use for the Laoss softwares. But in the Laoss software we can also create the geometry. You can see my first video of the introductory parts for the session. All the things available on my previous video. We are going to create in here the 100 mm type of geometry. For start of the create a new geometry, you need to set that the 100 mm. You can see, like if we have already set mm. Now you can use this type of snap grids, snap on the end point, snap of infinity, and snap centers, snap middles, snap distance, snap intersect. So each of the things which have the different meanings, so you can use. We are using the snap in points, so you can use the verticals. First you need to give in here that the length value like 100, and then you can move toward this sides and click. Now you can see. Now we are going to create horizontal lines like this, but you also need to give in here that 100 value like this, and then you move. They automatically selects and create like same for that bottom sides, and click like this. Now we are going to create verticals, same select like this and like so. One of that geometry for the 100 mm and 100 mm are created. You can also check like this 100. It is one of the simple geometry. You can also create various type of geometry. You can visit the LibreCAD tutorials if you want to see. we have already discussed about the Laoss geometry. You can directly import that file. Save Oled 100. When you have created that geometry, you can cut this. You can open Laoss software, run as an administrator. It is a Laoss GUI. You can see in our sessions video we have already discussed about the GUI and different tabs, how we can use. If you are going to create in here the new projects, you can use that tabs, but you can also see new projects, load projects, import from zip, sports, import geometry, and you can edit. Tools and settings also given in here, and Laoss manuals, tutorials, and Laoss release notes, gather supports, contact fluxim supports, you can see. So different tabs are available in here, but they will activate when we move toward the new project and give in here the name my first Oled Simulation. You can see large area and 3D ray tracing. When you move toward these tabs, you can calculate optical type of properties for the large area. You can also use that tab. You can use your own project part, and you can also set it in here like this. Click on that. OK. Now you can see the tabs are active in here. Various type of geometry given in here: TSF geometry files, Salom unit files, predefined geometries, predefined geometry metal fingers, predefined geometry metal strips, predefined geometry metal grids, and hexagonal metal grids. Different type of geometry given in here. You can create in here own type of geometry. We are going to create 100 mm type of rectangles. You can click like this, select as mm. Units are available in here: meter, centimeter, mm, micrometer, nanometers. And if you select like this 100 and 100, and when you click on this show geometry, you can see 100 mm and 100 mm geometry has automatically created in here. Defects: what type of defects? Like enable defects, number of defect, defect width, seed of the pair ng, and defect height. So you can also give that value, and then you can create that defect. But in here we are directly going to import from the LaborCAD geometry that you have created by your own selves. And about this we will be discuss on the different tutorials, but in here we are going to directly import that geometry like downloads and Oled. That's how we have created in the LaborCAD. Click like this. Now you can see that type of geometry. But if you are not directly imports from here, you can also use that tab. Import geometry. Load from files. Click down this Oled and apply and OK. This is the OK. But if you want to delete some things like this, you can zoom like this and move like this. We have created that type of geometry. If you click on this, so you can also edit or cut. You can see that check status: only line, intersecting line, duplicate lines, ready for defining subdomains, missing successful, load from files, convert to line, cut intersecting lines, remove steps. So points you can see in here. Boundary conditions, you can also create in here your own boundary conditions, and we are going to create in here that boundary conditions. But before the boundary conditions, you need to select that. Click one by one like this. Use the shift buttons and hold it, and then you can select all type of sites like this. And now you can click create boundary conditions and give in here that new names, each first, and then OK. And you can see like this. If you click on this, you can see for the subdomain, if you want to create in here that type of subdomain, you can also add subdomain. And if you want to add area in here, you can also add. Click on these tabs. So different tabs for the geometry you can create like this, and you can also import from different geometry apps, and then you can use this geometry in current project. Before use this geometry in current project tab, you can see all the ticks are right in here, and then use this project like this. So these the two type of process are available in here to import that geometry. After that, the geometry you can see meshing tools for the net generation and BMMG. For the greater accuracy, you can move toward that net gen. And minimalist size you can see, maximalist size you can see 0.1, 0.1, number of vertices, and mesh refined iterations and factors are available in here. It totally depend on the user which type of settings they want to do in here. And we can break and set in here the minimum is size or maximum is size, so it for the give the correct meshing type of structures like this. You have break that type of geometry, and if you zoom like this, you can see that the breaking different triangle, rectangle type of geometry. So whole that geometry have created in here, and that type of meshing you can do. After this you can move toward the device IVT tabs. You can see single electrode tabs and coupled electrode tabs and thermal couplings. If you move toward the thermal modules and temperature type of properties, you can use these tabs. No thermal coupling, heat generation only, and full electrical thermal couplings. Device type you can see OLED and PV, and simulation types like we are talking steady state and IAC. If you're setting like this, you can use, and different tabs are active in here. For the AC like this, parallel RC, imported curve, set for simulation, and steady states you can see ohm, mod करने, diode model, imported JVT curve, mathematical expressions, imported lambda JV curves, and set for simulations and set for simulation. In here you can integrate that your set for simulations type of files, so you can use. In here we need to select import JV curve like this. When you imported that the JV, you also need to import one of that files that known as the IV curve type of file. They are available on Laoss projects, so you can directly import. Example fonts generics. If you click on the examples, you can see IV curve. You need to import that IV OLED. They are available on the Laoss, so you can import from there and click on that OK. When you imported that files, you can see unit of the voltage, current density value, they are automatically saved in here, and luminance units, enable smoothings. If you enable this, you can use, and dark JV calculation can also. So you need to click in here that apply, and after the apply you can click that graph, so you can see that files we have imported, and we can simulate that files. After that simulation results, you can see current density and potential files. After that, the device IVT settings, you need to move that electrode. You need to select in here the no thermal coupling, because we are not going to calculate in here that thermal properties like this. After this, you can move toward the electrode tabs. By default, you can select, and sheet resistance value you can provide in here in the electrode tab as the top and bottom. You can see top you can give in the 20 ohms, and as a top, and bottom electrode at the sheet resistance, it is a default subdomain. That value correspond to 100 nms. You can see that the thick electrode with conductivity of 5 into 10 to the power 5 equivalent to P dot PSS as a top or bottom electrode conductivity. So you can give in here that 20, and bottom electrode as also 20 you can give in here. After this, you can move boundary conditions. You can set in here the voltage same as the voltage. Top and bottoms you can give, and the value automatically save in here the 00. Like you can see geometry composed of one each, but you can create same geometry with different number of each. It is depend on your applications part. When you click on the entity of each, first it appears red on the geometry to the reactive the geometry view like this. Now you can move toward the shift tabs. Enable shift settings and click on this. Now you can see different shifting parameters are available. You can shift that type of value, Ohm's law, and diode models like this, diode models and wavelengths, JV curves, thermal couplings. You can shift that type of parameters, luminance, frequency, and set force parameters. If you select that set force value, you can also shift that parameters, joule heating. So different shifts are given, but you need to select only the potential like this, and after that you can select each first. Now you can provide in here that shift value, select that the voltage will apply, and after that 0 shift from 0 to 9, and shift steps you can consider one, and target as the top electrode, but you can see linear log tabular type of file. Click on that OK, and you can see that target top, bottom, and both unit automatically voltage. If you want to optimize that type of parameter, you can see fit import IV curve optimization may XYZ. You can click like this every tabs which have the different work. So you can see we are going to disable in here because we are not going to set in here every parameters. But if you select like this, automatically tab will active. You can now add that the things are available. You can delete, and you can choose the disable. Now you can see that the solver performance or memory trade-offs. So depend on these settings, you can see simultaneous solver. It is too much fast and great process. So we select that. Also that direct sparse solvers and pre-calculate stiffness matrix. Yes, we need to calculate that things. Different convergence types criteria. You can select absolute residual for better ones and RMS. You can set in here that tolerance value 20 or 10. So I'm choosing in here the 10 iterations. You can choose 100. You can see that the tolerance not reach maximum number of iterations, Laoss will display error. So it only the convergence criteria given in here. After the complete setting, you can see geometric meshings, device IVT, electrode, boundary conditions, shape optimization, solver. Now you can click on that the run button and simulations going on in here. You can see after the simulations results, you can check one by one each of the results like total device current diagram, top ohmic lock, top ohmic losses diagram, bottom ohmic loss diagram, source power diagram, total power diagram, same as flux per boundary conditions, electrical current, top boundary condition is first, can see for the bottom and each of the potential like for the 0 and then you can check for the 1 volt. So one by one you can check like 5 potential applied on boundary each first on top electrode as the 5 volt, same for the potential applied on boundary each first on top electrode equal to 7 volts, potential top electrode, potential bottom electrode. So you can check one by one. So in here you can see total device current diagrams at the simulations runtimes. You can see total device current at the 0. Now you can check that different tabs, show geometry, check values, run meshings, x-axis, y-axis, flip x-axis at the different tabs or the different voltage that will enable. You can see potential counter lines, electrical intensity, electrical field arrow and electrical field lines. So which type of things that you want to select like this electrical fields how they are working, so you can check. So these are the my first last tutorials OLED simulations. In here we are discussed about only OLED simulation and it is the series of the last tutorial. Now I'm going to end here my last tutorials OLED simulations. If you have any query related to this, please ask in the comment box and my email are also given at the last side of the video. You can visit Simple's Technology and you can book also demo. Thank you very much.